Welcome back to Algebra 2 and Pre-Calculus. We're talking about real numbers today. It's another review video like last video. That was a review of sets. This is a review of real numbers. Soon we're going to have some other reviews about exponents and whatnot. Fun stuff from algebra, right? So I always say that review is the best form of preview because you need a strong foundation before you can build on top of it. So I strongly suggest you to watch these videos if you're taking an Algebra 2 or Pre-Calculus course, or even if you just want to learn more for fun. Anyway, back to this video. Let's jump right in with real numbers. So the first set of numbers we're going to learn about today are natural numbers. Natural numbers are basically any numbers you can count with. For example, 1, 2, 3, 4, all the way to infinity. We have 5, 6, 7, 8, basically numbers we learned in basic pre-algebra. The second set is called whole numbers. And these numbers are basically every single natural number plus a zero. So you start with a zero and you have all those natural numbers. So both of these are pretty basic that we learn in pre-algebra. After this, the second chapter of pre-algebra is probably dedicated to integers, either the second or the third depending on the textbook, but integers are the next thing that you learn. Integers are every whole number and its opposite. Its opposite is just the negative of each number. So for example, the negative of 1 or the opposite of 1 would be negative 1. In this case, we can write all the integers like 0, 1, 2. We still have all these all the way to infinity, but we also have negative 1 and negative 2 and all the way on this side to negative infinity. Those are integers. Now we talk about rational numbers. Rational numbers are probably in the middle of pre-algebra when you actually talk about fractions and decimals. The formal definition of rational numbers is that any number is a rational number if it can be written as a fraction. So what qualifies? Well, obviously a fraction like 2/3, negative 1/2. Even 1 is a fraction technically because you can write it as 1 over 1, which is a fraction, so it's a rational number. And then you also have decimals. Some decimals are rational numbers. There are two types of decimals that are rational numbers: terminating and repeating. Terminating decimals have a finite end. Like 0.25 is a terminating decimal. This is terminating because you have an end after 5. And you can even have 100 digits. You can have so many digits, but it'll still be terminating because it has an end, so you can always write it as a fraction, so it's always rational. After this, we have repeating decimals. Basically, they go on towards infinity, but there's a repeating pattern, like 0.33 bar. Whenever you see this bar symbol, that means it's a repeating decimal. So something like this, 0.33 bar, you can write it as 1/3. It might not look like a fraction, but it can definitely be written as a fraction. Any other decimals are not rational numbers, and we'll be covering that in a minute. But these are the first 4 sets of numbers that we're going to learn today. Now we're going to be talking about irrational numbers. Irrational numbers is basically any number that is not rational. So any number that cannot be written as a fraction. So if we think about it in terms of sets, because all of these are actually sets of numbers, and we talked about sets last time, well, we can write this as the complement of the rational numbers. Remember, a complement is any element. It's made up of any element that's not part of the set in discussion. So for example, if we're talking about instruments, musical instruments, and the set is pianos, the complement of that set would be anything that's not a piano. So for example, the guitar, the ukulele, the trumpet, all those are in the complement. So the irrational numbers would be the complement of the rational numbers. What are some examples of this? Well, pi. Pi is a number in geometry, a very important number, and it's approximately 3.1415. But it goes on. There's like 9 and 2, 6. The point is, it's infinite, it doesn't have a pattern, therefore it's neither terminating nor repeating, it's not a rational number. You can also have square roots. Square root of 2, which is approximately 1.41, is irrational. These are examples of irrational numbers, and these are pretty important, especially when we talk in pre-calculus about e. E is a number. Like pi, it's important, but this time it's important algebra 2 in pre-calculus, and it's approximately 2.718. These numbers are important because they don't have a finite number of digits, but they're very important, so we have to memorize at least the first few digits, like how I did 3.1415 and 1.41, 2.718. I'll get back to E in a very later video, like probably like a few, maybe 50 videos from now, because each one is supposed to be pretty short. I'll get to E and exponential functions a bit later, but for now, pi and root 2 are pretty important irrational numbers. So those are irrational numbers. Now we can represent numbers like these on something called a number line. And if you've taken pre-algebra, you probably know what a number line is. A number line is basically a long line that has all the numbers, or all the rational and irrational numbers on it. So we have the number 0, we have the number 1, 2. So these are all the whole numbers. We also have the integers, -1 and -2. We have rational numbers like 0.5 and -2/3. And we even have irrational numbers. We have root 2 over here. I told you it was around 1.41, and this is approximately 1.41. We have irrational numbers here. Square root of 3 is 1.7. Cube roots are also an example of irrational numbers, I was about to say. We can list them here too. But all of these are just rational and irrational. And we have a name for both rational or irrational. It's called real numbers, and that's the topic of today's video. Real numbers are numbers that are either rational or irrational. So any rational or irrational number is in this. And remember, if we talk about sets, we can say that it's the union of rational and irrational numbers. We can also say that rational and irrational numbers don't share any elements. There can't be any number that is both rational and irrational, so they are disjoint sets. The real numbers is the union of these two sets, and it's basically all the numbers that lie on the number line. That's the basic definition of a real number. So that's it for today's video. Next week, we'll be continuing real numbers, and we'll be talking about properties of real numbers, like commutative properties and associative properties and fun stuff like that, right? So I hope you enjoyed today's video. Let me know in the comments below if this is helpful, and see you in our next video.